section, we will be graphing the solution set of a linear inequality in two variables. Beginning with example 1. Here we have y is less than 5 minus 3x. Now the first thing we want to do when graphing the solution set to a linear inequality is to graph the line itself. Now the line itself may or may not be part of the solution set, but it does divide the plane, the Cartesian plane. So we need to have the line drawn, and then we can indicate whether or not it's actually included in the solution set. Now in order to do this, it's a lot easier to think of this expression, y is less than 5 minus 3x, and write it as an equation just for the purposes of drawing the line. So what we're actually going to graph is y equals 5 minus 3x. Now looking at this, the vertical intercept is going to be 0, 5, and the slope is negative 3. So from that vertical intercept, we're going to go down 3 units and right 1. There we have a point. Down 3 units, right 1 again. Down 3 units, right 1, and so forth. And before we draw the line connecting them, we need to decide whether the line itself is in the solution set. So we're looking at the inequality symbol that is given in the problem. If it is strictly less than or strictly greater than, that indicates that the line itself is not part of the solution set. So we indicate this in our graph by drawing the line using a dashed line or a dotted line. We don't actually draw the entire line. So I'm just going to draw the dotted line here on my graph because the line itself is not actually part of the solution set, but it does divide the Cartesian plane. It does split it into the two regions, one of which will be our solution set. So now we just have to figure out which side of the line our solution set is on. So we need to pick a test point. The test point has to be a point that is not on the line. Any point that is not on the line. My favorite is 0, 0. If at all possible, 0, 0 just makes it so much easier, just because zeros are so easy to work with. So I'm going to choose 0, 0 as my test point and plug it into the given inequality. Y is less than 5 minus 3x. So I'm going to plug in a 0 for x. So I am just going to plug in 0 for x and 0 for y. So 0 is less than 5 minus 3 times 0. 0 is less than 5 minus 0, or 0 is less than 5. This is true. So that indicates that the ordered pair 0, 0 is part of the solution set. So that means that every point on this side of the line, the same side as 0, 0, is also part of the solution set. So I'm going to shade the region here that is to the left or underneath the line. Example 2. Here we have 3x minus 2y is greater than or equal to 6. Our first step is to graph the line. We want to make sure we can draw the line on the plane, and then we can decide whether or not to include it in our solution set. So to graph, you want to change the inequality to an equality sign. So 3x minus 2y equals 6. And solving for y, I want to write it in slope-intercept form. I'm going to subtract 3x from both sides. That gives me negative 2y equals 6 minus 3x. Divide both sides by negative 2, and we wind up with y is equal to 6 divided by negative 2 is negative 3. Minus 3x divided by negative 2, the negatives will cancel and give us plus 3/2 x. So this is what we're graphing. The vertical intercept is 0, negative 3. and the slope is 3/2. So from this, we would go up 3 units, right 2, up 3 units, right 2, and so forth, or down 3 units, left 2. And looking at the inequality sign, it is greater than or equal to. So our solution set does include the line itself, so I'm going to connect these points with a solid line, indicating that the line itself is part of the solution set. Now we have to check and see which side of the line is the points in our solution set. So 0, 0, always a favorite test point. 3 times 0 minus 2 times 0 is greater than or equal to 6. You always want to plug it into your original problem. 3 times 0 is 0, minus 2 times 0 is 0, gives us 0 on the left-hand side, is greater than or equal to 6. 0 greater than or equal to 6, that is not true. That is not a true statement. So that tells you that 0, 0 is not part of the solution set. 0, 0 is right here. It is not part of the solution set. So the solution set is going to be on the other side of the line. So I'm going to shade the region here. Example 3, we have y is greater than or equal to 2x. So same as before, start by graphing the line. Graph y equals 2x. Now here the vertical intercept is going to be 0, 0, and the slope is 2, so we're going to go up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1, and so forth. And looking at this inequality, we have greater than or equal to. So it is going to be a solid line connecting the points. And now we have to choose a test point. Now, because 0, 0 is on the line, we cannot use it as our test point. We have to choose a point that is not on the line. So I'm just going to write a little note here, can't use 0, 0 as a test point because it is on the line. Your test point has to be a point that is not actually on the line. So choose a different point. It could be any other point provided that it's not on the line. So I'm just going to take this one right here. This is 3, 0. So 3, 0. Plugging that point into our original problems. So y is greater than or equal to 2x. Y is 0. It's greater than or equal to 2 times x is 3. 0 is greater than or equal to 6. That is not true. So the ordered pair 3, 0 is not in our solution set. So we're going to shade on the other side of the line.